Okay, so here we are on page 238 with an example. Happen to do number 12. By the way, it says in the stem of these problems that you may want to simplify the problem before you take the derivative using some log rules, which I know you learned in Math 50. I will just post a quick video of what those rules are. It'll come back to you. It's just equivalency rules. So anyway, here we need to take the derivative of p of x with respect to x. And in order to do so, it's good to remind ourselves that this function can act like a power instead of just a root. This is nice that the derivative of this is just 0, so that's going to go away. And ln x, if we have ln x as a function, our derivative winds up 1 over x, but the chain rule applies. So if this was ln of u, some function, then we would have the derivative of u divided by x, because it would be, or the derivative of u divided by u rather, because we would take 1 over x and then multiply it by the derivative of x, which winds up in the numerator. But before I do this, actually, I think it makes sense to write this down a little different way. So let's write this down this way. ln of x raised to the 1/3 power plus 1.2. So that's still p of x. Okay, we haven't taken the derivative there. Now, this looks like a power rule with ln x inside of it. So first thing I'm going to do is 1/3 of ln x. And then this ln x is now going to be raised to 1/3 minus 1, or negative 2/3. And then we have to follow the chain rule. So we have to take the derivative of what's inside. That's going to be times 1 over x. Now, if x were a function, I'd then have to multiply it by the derivative of x, but the derivative of x is just 1, so we're set on that. And then plus the derivative of 1.2, which is 0. Now, this was written as a radical, so we're not going to leave this way. And we're also not going to leave that negative exponent. So d of px over d of x. This 3 is in the denominator. This ln x is actually in the denominator. This x is in the denominator. The only thing left in the numerator here is 1. So we have 3 and we have x. And then we have the 3rd root of ln x squared. Now notice I put these parentheses around ln x because if I just square the x, I'm squaring the argument. And here what's actually being done is the whole ln x, function is being squared and 3rd rooted. So that's a nice format for the answer. I'm going to come back with a quick video just to show some rules to remember from Math 50. And then also I'm going to summarize some of these rules on your chart.